Hello, everyone. Welcome to our webinar on Bluetooth Low Energy Mesh, Features and Applications. I'm Jason Montgomery, your host for today's webinar. I'd like to welcome our presenter, Pavan Mullabagal. Pavan Mullabagal is part of the IoT strategy and marketing team at Semiconductor. In this role, he's responsible for driving IoT initiatives, customer and partner engagements, and evangelizing Semiconductor's IoT products and solutions, spanning everything from sensors to connectivity solutions, actuators, and SoCs. During his 17+ years in the high-tech industry, Pavan has launched a number of wearable, mobile, consumer, and networking products. Pavan holds an MBA from Haas School of Business, Berkeley, and a BSEE from the Indian Institute of Technology. Pavan, welcome.
Thank you, Jason.
Everyone, please,
welcome, everyone.
Of course. Thank you. Please be sure to use your Q&A widget to submit your questions. And if we don't get through all your questions during the Q&A session, then a reply will be sent via email. And with that, let's get started, Pavan. So over to you.
All right. Thanks again, Jason. Welcome, everyone. Good day to you all. Thanks for joining us. Today, we'll talk about Bluetooth Low Energy Mesh. It's an interesting new addition to the Bluetooth Low Energy family. We'll cover a little bit about the features. There is extensive documentation and details available on the Bluetooth SIG webpage. What we will do during this call is just highlight a few of those. We'll talk a little bit on some of the terms that get used, why we need mesh, what are the benefits, what are the features of Bluetooth Low Energy Mesh. There will be a brief discussion on comparing a Bluetooth Low Energy Mesh with ZigBee, which is another popular indoor/personal area network. And we'll wrap it up by talking about the RSL10 Mesh Kit. RSL10 is our Bluetooth Low Energy SoC. We launched it about a year plus ago. And we'll talk briefly about the kit and what sort of features it allows one to exercise. So with that, let's get started. Just an overall picture about the Bluetooth market itself. Bluetooth has been among the most successful personal area networking technologies out there. And all of us carry multiple devices which all have a version of Bluetooth in them, be it the basic Bluetooth basic rate, enhanced data rate, or what is known as a classic Bluetooth, which started off as a wire replacement or cable replacement technology, to Bluetooth Low Energy, which was launched over a decade plus ago, which enabled a lot of interesting use cases. Now, with the advent of mesh technology, Bluetooth has made significant strides. And purely from market numbers, the projections from ABI, which is shown on the left plot there, indicate a very steady growth to about 6 billion units shipped by 2024. So that's the overall Bluetooth market itself. And within that, mesh is the new candidate on the block. Mesh was released about 2.5 years ago by the Bluetooth SIG. And there aren't enough market statistics yet, but one thing that I found in the market data published by the Bluetooth SIG is the number of qualified devices. Think of these as the number of deployments of mesh technologies, or potential deployments. And it's a very encouraging sign. It's doubling every 6 months. And I think from inception, so we are probably at the 24 to 30 month mark. And there are a significant number of mesh qualifications that the Bluetooth SIG has undertaken, which tells us that the deployments are accelerating and people are investing in mesh technologies. In terms of applications, the biggest and the most widely adopted use case for Bluetooth mesh is on the lighting side. This is something that we see when we deal with our customers as well. And this is borne out by the market research that Bluetooth SIG has done as well. So over 90% from their estimates is what 90% of use cases is what pertain to lighting. when it comes to Bluetooth mesh. So again, I thought we'll start with very basic terminology in terms of the network topology itself. Most of us who spend time in the IT world are familiar with this sort of a topology, which is applicable across wireless networks. Bluetooth is no different. It started off being one-to-one or point-to-point. In Bluetooth parlance, they also call it piconet, where one device, one master device can connect, has a one-on-one relationship with a slave device. That's how it started. And then with the introduction of Bluetooth Low Energy over a decade plus ago, this sort of beaconing or advertisement or broadcasting devices were introduced. This is the middle picture. And Bluetooth Mesh is the one that starts talking about many-to-many. Nodes can communicate with each other without having to go to a centralized location or a master device. And there are several benefits of doing that. And among them, a key benefit is extending range. This is, again, fairly intuitive concept, given that a device can communicate with its neighbors and the messages can hop from one device to another. Implies that the range of your network is expanded, it's extended. And this allows personal area networking technologies such as Bluetooth, even ZigBee, to span large physical distances. Think of a building with 20, 30 floors, commercial buildings, and having the ability to communicate among the various floors and within a given floor. Think of factory settings. All these are enabled now with mesh technologies. Bluetooth Low Energy Mesh specifically uses what is called as a managed flooding, and we'll talk a little bit more later, but essentially the idea is any node that receives a message can transmit it out to other nodes that pick up the message, and then the transmission of a message continues in that fashion. Of course, there are smarts built into the system so that the whole network doesn't get congested, and that's the quote-unquote managed part of the managed flooding. Bluetooth Low Energy uses that. The other key benefit of a mesh network is resiliency. Again, there isn't. This is especially true of a Bluetooth mesh network. There isn't like a central device. So if a device goes down, there are alternative paths. There's no single point of failure, and devices or messages typically take multiple paths to get from a source to a destination, and this inherently provides resiliency within the network. It's fairly scalable. The way the protocol has been designed, it allows very easy addition of devices, and it's fairly reliable as well. So these are some of the benefits of mesh network, and specifically Bluetooth Low Energy Mesh. And this is one of the reasons why Bluetooth SIG also started getting into the mesh networking side of things. So from a stack standpoint, for the next 5 or 6 slides, we'll dig deeper into the Bluetooth mesh and the protocol itself, how it is structured, starting with the sort of the physical layer. One key aspect is Bluetooth mesh runs over Bluetooth Low Energy. So implicitly, any device that supports mesh needs to have a Bluetooth Low Energy stack on it. And beyond that, there are multiple layers defined by the protocol itself. Just like any sort of an OSI kind of a stack, there are layers that have specific functionality, and the layers talk to the layers above them and below them. And in the case of Bluetooth mesh, there are about 6 or 7 layers that are important in making sure the communication and the network itself is robust. The data itself, the physical channels used are what are called advertising channels. So just as a quick background, Bluetooth Low Energy uses 40 channels, each channel about 2 megahertz in bandwidth, and this is a 2.4 gigahertz ISM band. Within those 40 channels, 3 of these located on those shaded regions, 3 of these are designated as advertising mode channels. They are numbered 37, 38, and 39. And most of the mesh communication happens on those channels. And there are devices, legacy devices, that can communicate with mesh networking devices, and they can use other channels as well, specifically what is called the proxy node. We'll talk a little bit more about that. but the majority of the communication does happen on 37 channels, 37, 38, 39, which are also known as advertising mode channels. All right, so now when it comes to the devices and how they get onto the network, some terminology that is kind of widely used within this mesh networking space. A device which has a mesh stack on it, but it's not part of any network, is just called an unprovisioned device. There is a process called provisioning, which I will talk in a couple of slides, that securely onboards a device onto a network. At that instance, it becomes a node that is part of a Bluetooth mesh network. All nodes can transmit and receive messages within a Bluetooth mesh. And there are optional features. Some of the nodes can have additional functionality, and those functionality are defined in the specification itself, and those are critical to enabling this mesh network. The optional features or the optional node types are shown on this slide. For example, there is a relay node. Relay nodes within a mesh network serve a very important function. These are the nodes that have been designated as forwarding messages. As I mentioned previously, although all nodes can transmit and receive messages, you don't want that in a network. You want to sort of somewhat plan your network so that you have these relay nodes placed at important junctions where they can take a message from one group of devices and can relay them to other set of devices. So the main function of a relay node is it receives and rebroadcasts messages. However, there are smarts built into the protocol itself so that this process doesn't become completely messy with a lot of devices transmitting same messages. There are heartbeat messages, and there are time to live fields within messages that allow a relay device to act in a somewhat smart manner in deciding to forward a particular message or not. So the relay nodes are quite important for the functioning of the mesh network, and these are the ones that take the messages from one source and through multiple hops get it to a particular destination. Then an important type of a node is a proxy node. And the reason why a proxy node had to be even created is because mesh came is a recent standard, and it came about after the whole ecosystem of smartphones had the Bluetooth low energy chips and associated software in them, but they did not have a mesh stack in order to be able to communicate with legacy devices. And why would you want to do that? There could be several reasons. Like once you have your mesh network set up, maybe you want to configure, you want to change settings, you want to do some other stuff related to the network itself, but the device that you want to do it on does not have a mesh stack. So in cases like that, a device within your mesh network would work as a proxy device, and it can communicate on what is called the GATT, which is the traditional Bluetooth low energy way of communicating, standard BLE communication methodology, with a device like a smartphone that does not have mesh, and this proxy node also can participate in the mesh network itself. This way, you can take a legacy device and have it access the mesh network. So proxy nodes enable that functionality. Then the other interesting and very unique attribute of this whole protocol is the whole concept of friendship. And this is shown on the right side of the slide here. The friendship concept is a very interesting one and is very useful, especially when you have extremely low power nodes within your network. The whole idea of friendship is this. For devices that are, let's say, battery powered, and in some cases, they could even be powered using energy harvesting services. So you want to conserve the battery as much as possible, but keeping these devices awake all the time will drain the battery. At the same time, you want to ensure that these devices do not lose any messages intended to them. And that's where this whole concept of friendship comes into play. Low power nodes associate themselves with a node that is designated as a friend node. Believe it or not, those are all official terminology, friend nodes and friendship. And when the low power node associates with the friend node, it can go off to sleep. It's the friend node's responsibility to cache messages designated to go to low power nodes. So whenever the low power node wakes up, it probes the friend node and asks if it has any messages, and the friend node is responsible for sending those messages back. So this is a very powerful concept, and this is what enables the mesh network to have various kinds of devices within it. You can have wall powered or AC powered devices like lighting fixtures that can serve as friend nodes because power is not an issue there and they can be always on. And they can talk to sensor nodes that are attached to, let's say, your window or your lighting or your door to monitor temperature or any other ambient conditions. And these devices can all be part of the same mesh network through this concept called friendship. So these are all some of the optional features that are defined within the mesh network itself. So in a typical mesh network, what you will see is you will have a mixture of all these kinds of nodes. Obviously, relay nodes are important if you want to get the extended range, if you want to talk to devices that are spread out. The function of relay nodes is to, again, relay the messages through multiple hops. Proxy nodes allow devices that don't have a mesh stack to participate within a mesh network. And obviously, we talked about the low power node and the friendship concept that allows extremely energy constrained devices to participate in a mesh network. In this graphic, for example, you see on the left-hand side, there is a temperature sensor. Obviously, it's a battery-powered sensor, and it associates itself with a lighting fixture, for example. The lighting fixture becomes its friend node, and it measures temperature periodically, sends it to the light node, and whenever it wakes up, it also pings the friend node and asks if there are any messages that are destined to the low-power node. So a typical network is something that looks like this. And in general, it's also a good concept to, I mean, a single node can serve as all of these, but it's not a good idea to have a single node serve as various functions because you'll get too clogged, as well as the computation requirements go up significantly. So this is how a typical mesh network is laid out. So we talked about provisioning. Provisioning is also a secure process. This is how an unprovisioned node becomes a part of a mesh network. And this process of provisioning is involved in distributing securely various kinds of keys. We'll talk a little bit more about the keys a little later. But there is a network key, a device key, as well as it'll provide some addresses. The device itself that is getting added to the mesh network can request to be added to certain group addresses, if you will. And all of this process happens in a secure fashion. There are different phases involved in provisioning. It starts off with a new device that you bring on, and the one that wants to get connected to a mesh. It starts off by sending specific advertisement packets saying, like, look, I want to connect to a particular mesh network. And the provisioner, the device that adds these unprovisioned nodes into a mesh network, sends an invitation, public keys are exchanged, authentication happens, and a whole bunch of data gets exchanged. And all of this happens in a secure fashion. And this whole process is what kicks off adding a new device into a mesh network. All right, now, how do devices communicate on this on Bluetooth mesh? All communication on mesh happens through messages. And the messages are sent either to a particular device, what's called as a node or an element within a node. I'll tell you what an element is slightly later. Or it's sent to a group address or a virtual address. I'll also describe what I mean by those terms. There are, at a high level, there are only about 3 types of messages. Those are the get message, like essentially think of it as a query. Okay, get me the temperature, get me the status of the window, is it open or closed? Set messages, these are messages that you are setting a certain parameter within your device. Things like set the thermostat to this temperature, or open the door, those kind of messages. And then the third category is the status messages. Anytime you send a get message, the response comes back in a status message. Or anytime you send a set message and request it to be acknowledged, that comes back in a status message. So at a high level, there are only these three kinds of messages. The key concept underlying the whole BLE mesh messaging is it happens using what's called as publish and subscribe. Certain other protocols also have this same kind of methodology, where anything devices that have information, they publish to a certain address. For example, let's say there is a temperature sensor, or there is a bunch of switches, as is shown on the graphic on the right, and they say, hey, somebody turned me on, somebody turned off the switch. It sends to a particular address, and in this case, the address have sort of human recognizable names like a kitchen or a dining room or a bedroom, and the switch itself transmits or publishes message to that particular address. Now, the devices that need that information subscribe to that particular address. So in this case, in the example on the right, you will see that switches or bulbs, lights 1, 2, 3 subscribe to this kitchen topic or kitchen address. And the beauty of this is, I mean, you can easily scale this. Let's say you add one more light into your in the kitchen, and all you need to do is during provisioning, when you provision the device, you need to tell the light in the kitchen to subscribe to the kitchen address. And a single switch, for example, in this case, switch A, that controls all the kitchen lights, can be used. It sends a message to the kitchen address, and anybody who subscribes to the kitchen address will receive that message and take the appropriate action. As you can see on the graphic there, you can a light can or a node can subscribe to multiple addresses. So in this case, node 3 does subscribe to the kitchen as well as dining room. It's probably a lighting fixture in a hallway that connects these two. And it works the other way around also. If you look at switches E and F, they both publish to the garden address. And maybe you have multiple switches. This way of transporting messages, this way of how the messages are communicated in the mesh network scenario is extremely powerful and extremely flexible. I mean, this is what enables massive scale deployments. You can add new devices without actually disrupting any of the existing network, and you just need to know what addresses to subscribe to. So fundamentally, BLE messages are based on publish, subscribe, and from message types, there are like 3 types: get, set, and status messages. Some other features or aspects of the BLE devices themselves. On the bottom right, you do see what is called a node. This could be your lighting fixture, this could be your switch or a thermostat, or your Bluetooth low energy connected door lock. And within a node, there are multiple elements. It's not mandatory, but for, I mean, think of a standard example that's given is the lighting fixture that has independently controllable lights in it. And those would be the 3 or 4, how many ever lights you have in that fixture, those would be the elements within the node. And each element will have various models. I'll briefly tell you what models are. But that's sort of the general layout of a node itself. A node comprises of multiple elements, again, optional. It'll have at least one element, and the elements comprise of various multiple models. It'll have a base model and multiple other optional models it might support. Now, what is a model? Model is something that encapsulates the entire behavior. And just like we have seen with messages, models also at a high level come in like 3 varieties. One would be a server model, a client model and a control, what's called a control model. Think of the server as something that has state in it, and it defines how the state transitions happen. It defines what are the bindings. If you have multiple states, how do the states interact with each other? As an example, on the top right, you do see an LED light, and it does implement, let's say, something called as a generic on-off model. In this on-off model, what you see is it implements these generic on-off states, and which can be controlled using the corresponding generic on-off client model. Models also three types, and the best way to think about models is look at the example on the top right, where you have an LED or a light bulb which implements a generic on-off server model, and the switch that controls it implements a generic on-off client model. Server models have states. Client models issue messages to control the state and the behavior of these of the server corresponding server models. And so there's something called as a control model that includes both a server and a client, and the RSL10 mesh kit that we launched does implement quite a few control models, and we'll mention that towards the end of the presentation. Security. Security is an important concept within any sort of connected devices. The Bluetooth Low Energy, it's a BLE, which was introduced, I believe, 2008 or 9 kind of time frame. Security was completely optional. It was left. It was left to the device manufacturer or the system or the system integrator to figure out if they needed security. Everything was optional. There were hooks available. There was secure pairing available. All of those were available. But the BLE protocol itself did not mandate any security requirements. That changed with BLE Mesh because of the way and because of the ability to access a broader network and things like that. Security was made mandatory for Mesh. So security is mandatory as far as BLE Mesh is concerned. And the way security is handled is through the usage of keys. And within a mesh network, there are multiple keys that get used. For example, there are network keys, there's application keys, and there are device keys. And at a high level, the reason why you want these multiple keys is different parts of a message are encrypted using different keys. And the thing that Bluetooth SIG emphasizes is this is done for separation of concerns. As a standard example, for example, if a node is serving as a relay node, it just needs to figure out which network it belongs to, and it should take that. And if the message is not intended for the relay node, it should just forward it along. There is absolutely no reason for that node to have access to the application data, and that's what is meant by the separation of concerns phrase. That's the reason why you have these different kinds of keys. The network key allows you to be part of the network, and application keys or device keys add additional layers of security on top so that certain sections are accessible only to the intended recipients. The protocol itself has a very robust way using sequence numbers and initialization vectors to avoid replay attacks. There is a methodology provided to take out a device from the network in a prescribed fashion that will allow these kind of trash can attacks where somebody picks up a device that's been discarded and has access to all these keys. Privacy is built into the network. All of these are sort of supported by things like key refresh procedures that are defined within the protocol. So keys do get refreshed periodically, making it a robust, secure standard. Last but not least, of course, the security protocols themselves, the cryptographic algorithms used are fairly standard ones. Cryptographic message authentication codes and AES-based CCM codes for authentication and encryption. they are fairly prevalent in BLE mesh. So mesh security has been designed in as part of the mesh protocol itself. And again, the goal of the protocol designers was to make sure this network is as robust and as secure as possible. So that was sort of a very quick rundown of some of the key features of BLE mesh technology. Of course, each of these topics can take multiple hours to get into details with. And as I mentioned at the beginning, Bluetooth SIG does a fantastic job of documenting, having webinars, having blog posts, etc., on their website where you can get into a lot more detail. And of course, the other key thing that we want to talk now is about the various applications that are enabled by BLE mesh. Again, these are some of the obvious ones that that we come across, especially within the industrial and consumer space. And for example, on the home automation side, connecting a entire home network using Bluetooth mesh. It's a fledgling protocol, and we have just started seeing a few of these implementations. We do see a lot more activity on the lighting side of things, on the retail smart building, tying sort of islands of networks, like things like asset tracking and location services, tying them all together, and even within a healthcare setting, within hospitals. We do see slow adoption of mesh-related technologies. So with that, I thought I'd spend like maybe about a minute just talking about another technology that gets talked about along with Bluetooth and Bluetooth mesh. That's ZigBee, and obviously ZigBee is another personal area networking standard that has a lot of similar kind of features and enables a lot of similar use cases. It's fairly popular in industrial settings, and a big advantage that Bluetooth has, of course, is that all of us walk around with a Bluetooth gateway in our handsets, in our mobile devices. With that said, specifically when it comes to mesh, ZigBee does is inherently mesh capable. ZigBee is a networking technology which is based on IEEE 802.15.4 standards. It's been around for 15 plus years or more, in fact. And the way it handles the mesh network is what's called as a routed topology. Basically, messages take a specified route from source to destination, and that's a key distinction between ZigBee mesh and also Bluetooth mesh. Bluetooth mesh uses managed flooding. And there are some benefits. There are pros and cons to routed topologies. There are lots of companies that have devices that are interoperable, that work within a ZigBee network. And from a node standpoint, typical ZigBee networks consist of coordinators, routers, and end nodes. So ZigBee has been around, and we do see usage of ZigBee in industrial settings, and it does make use of this sort of routing where a message from point A to point B takes a particular route, and if something goes down in between, the routes are updated, and that's how you get resiliency within a ZigBee network. And just to summarize the Bluetooth mesh, as we talked about, it's a recent standard. It uses managed flooding. What that means is all relay nodes just blast out the message, but they don't indiscriminately do it. They make sure certain things are followed. They make sure that if they've already seen the message, they discard it. And if the message's payload contains, there's a payload field called time to live, and if it has expired, then the message is discarded, things of that nature. We talked about publish subscribe model. This is what a Bluetooth mesh uses. The other key feature that Bluetooth enables, and I mean, there's an equivalent on ZigBee side as well, but this whole concept of friendship that allows extremely low power devices to be part of Bluetooth Low Energy Mesh Network. ZigBee has an equivalent thing called a ZigBee Green Power, which is a protocol that allows running devices on extremely energy-constrained batteries or even energy harvesting devices. And Bluetooth Mesh runs on advertisements. The 3 channels that are dedicated for advertisement. It builds on, it runs and it uses those 3 channels for communication within the mesh network. So bottom line, there are devices, there are mesh networks out there with ZigBee. Bluetooth is a fairly recent standard, and a lot more newer applications, especially to do with lighting. We are seeing the adoption of Bluetooth mesh. All right, so with that, what I wanted to do is just maybe spend the next 1 or 2 slides, talk a little bit about the RSL10 mesh networking kit. What we have noticed is it's one thing to have all of this features available in software, and an easy way for customers to test things out is to provide these sort of development kits and that they can use to quickly test out the various features. The mesh, as we just scratch the surface, and within that there are various types of things that you can do on a mesh, various ways you can configure the network, various node types, the way you set messages, you get messages, they're all different, and where you place the relay nodes, etc. There's a whole lot of things that need to be figured out, and an easy way to allow our customers to do that is using this mesh networking kit that we launched recently. It's basically think of it as a development kit. It's easily configurable. It has a whole bunch of sensors and actuators on it. So sensors can be used to read data, and actuators, you can do something with them, with that data that's read. This networking kit does connect to our Strata Developer Studio. This is a desktop-based application, and that's the application that allows you to control and configure the entire mesh network, and it goes well beyond that. Strata itself allows you to have access to the various documentation related to the parts and design files, software, etc. So you plug in one of these boards, and it'll serve, and then use that to configure the entire network. It is all available, of course, freely downloadable from our website once you procure the mesh networking kit. Again, the goal for us is expose our customers to the product, to the chipsets that we have on Bluetooth Low Energy, and to expose them to the various software stacks that are available that can exercise the Bluetooth Low Energy mesh. This particular kit, the Strata with the Strata software running on a laptop will serve as a provisioner. One thing I didn't mention in the previous slide is there is a mobile app that you could use potentially as a provisioner as well. So all these features are available, and each of these boards is configured out of the box as a control node. So they do have both server models and client models. So when you have like a sensor kind of a network where they're measuring data, things like temperature, ambient light, or magnetic field, all of those can be read from these boards. And then there are actuator models for sound buzzers and beeping, etc. So it's a very comprehensive kit for you to play around with and to create your own mesh network to get a sense for how to deploy in a real world scenario. And this was launched about a month ago or so, and I definitely highly encourage those of you who are interested to go and get hold of this kit to see what we offer in this space. With that, I'll quickly summarize what we went through. Obviously, mesh networks aid in extending range and also provide a certain amount of resiliency, and that's why they are popular in certain settings. Bluetooth mesh is a fairly recent protocol. It was introduced in summer of 2017, and it runs on top of Bluetooth Low Energy. It's a managed network in the sense that you would position your relay nodes in the right places so that you don't degrade the network performance, you don't unnecessarily transmit messages. It does have a very detailed options and features that allow different kinds of nodes, things like friendship, proxy nodes, things like relay nodes, things like low power nodes can all be part of this mesh network. Message formats and everything is very detailed listing of what type of messages are supported, what type of models are supported, compatibility with smartphones. They're all part of the Bluetooth mesh network stack and protocol. Security is built into the mesh network. Security is another key area for a lot of IoT-related products, and Bluetooth mesh has security built into it. And last but not least, it does support low power battery power or low power energy harvested or battery powered nodes through this concept called friendship. So all in all, it's a very exciting protocol. We are seeing quite a bit of activity around Bluetooth mesh, specifically lighting. We are also seeing some activity as it concerns building automation and sensor networks within buildings. They're all starting to use Bluetooth mesh as the underlying protocol layer. And one last plug for RSL10. RSL10 is our Bluetooth 5 SoC. This is a Cortex M3. It's a full-featured. It's got plenty of flash and RAM, and it's the biggest differentiator is it's the industry's lowest power Bluetooth 5 SoC. It's available. The link's provided there. Please go check it out. And it's not just the SoC, but the associated software with it, with certified stacks, models, source code, example, and even mobile applications. They're all available for you to get a quick grasp of how this whole thing works and aid in rapid deployment. In addition to the SoC itself, we do provide various development platforms. The mesh platform is something that we briefly talked about. There's lighting, there's multi-sensor platforms. All of those you can make use of to test out the various features of mesh and see how you can use Bluetooth low energy or Bluetooth low energy mesh in your products. So hopefully this was helpful. This was, again, I realize it's not easy to cover all the aspects of Bluetooth low energy mesh in a 45-minute conversation. But as I mentioned, Bluetooth.com, the SIG has plenty of resources to read about Bluetooth mesh and additional details. And then I encourage you to go check out RSL10 from onsemi for what that particular chip and the software it enables. With that, I thank you all for your time, and maybe we'll take some questions.
Yes, thank you, Pavan, for that great overview. We can take a few minutes and dive deeper in with a few questions that we've gotten from our audience. And for our live audience that is out there, if you do have any other questions, this is a great time to submit those while we're going through just a couple more that we've gotten during the presentation as well. So our first question is, can I run multi-room audio using BLE mesh?
Unfortunately, no. A Bluetooth low energy mesh specifically is geared for short messages. These are almost, think of them as control messages, reading status of sensors and controlling things. That's its initial purpose, and that's what it's been designed for. Some of you might have seen the recent announcement with the Bluetooth 5.2. The BLE Bluetooth Low Energy radio itself now has support for audio. Classic Bluetooth has been supporting audio for a while now, and in fact that was the killer use case for a lot of classic Bluetooth devices, and it was a killer use case when it was launched. Now Bluetooth Low Energy also has a support for audio, but Bluetooth Low Energy mesh itself will not support multi-room audio. It's not geared for those kind of streaming channels. It's a message-oriented protocol, and as we saw, it's mostly for control kind of messages, reading sensor data from one place, transmitting that to different actuators, taking actions, those are the kind of use cases that are geared for BLE mesh, not multi-room audio.
Got it. Our next question is, what is the range of Bluetooth Low Energy?
Yeah, this is something that comes up fairly often. In short, it depends. And the reason why it depends is just like any radio frequency-based technology, the environment matters a lot. There are certain parameters that are important as it pertains to range. Obviously, your transmit power. A typical setting for transmit power is somewhere between 0 to 6 dBm. You don't exceed that for power reasons. So transmit power plays a role, and also the receive sensitivity, as well as the kind of antennas you've used in your setting, and most importantly, the kind of environment you're in. If it is a manufacturing floor and it's a fairly open spacing with the gateways on top, having a good view of all the various nodes, you might get a higher range. So it's hard to give a specific number to this question, but tens to hundreds of meters is something that we have seen in practical deployments. And Bluetooth, actually, if you go to Bluetooth.com or even Google rangefinder, Bluetooth Low Energy range estimator, I think it's called. They do provide a simple GUI that you can play around with. You can control things like transmit power, antenna gains, and sort of they have some models for different kind of settings, like an indoor setting or an outdoor setting and things of that nature. You can just play around to get a rough sense for what this range is going to be. The other important thing is Bluetooth Low Energy itself has defined various various data rates, if you will, various data rates and modulation schemes, and they also have a bearing on the range. There is something called as coded phi that was defined as part of BLE, forget which number, but it's part of the Bluetooth Low Energy standard, where the whole idea is to reduce the data rate to get a higher range and without increasing your transmit power. So all of these can be modeled and played around with if you go to the Bluetooth.com website and look for the range estimator. Again, bottom line, it depends on the RF environment, and with our customers, we have seen tens to hundreds of meters, plenty enough for home/building kind of use cases.
All right, thank you. We've had a couple people have asked a similar question here, and the basic question is, how many nodes can take part in a mesh, or is there a limit to the number of nodes?
The protocol itself, I think there is a limit, and if I'm not wrong, the limit is 32, basically 2 to the 15, 32,000 nodes. It's either 32,000 or 64,000. You'll hardly ever reach those kind of numbers. What is interesting though is one of the things that you want to watch out for is how many nodes do you place in a given area. Even though the Bluetooth Low Energy messages are short, the protocol itself is not designed. It doesn't listen to the medium, so it just picks up, sends its messages, and goes back. Does it something else? So you need to make sure that you avoid collisions by not packing them way too densely. So the practical limitation comes from having a certain number of messages within a given area. And that number is also fairly high. Like I remember seeing something in the 200, 250 messages per second within a given area, a small area. But to answer the question concretely, practical limitation is around 32,000 or 60. I think it's 32,000 devices are nodes are the ones that are the number of nodes that you can have in a mesh network. I have not seen a deployment so far where that started becoming an issue. What's more important is also the placement of where you put your relay nodes versus so that you get good extended coverage and things like that.
Okay. Another question that we have here, is there any indication of the message propagation time through the system?
That's a good question. Indication, let me take a, basically there is, depending on the number of hops a message has to take, you get a certain sense for how far a particular, or how long a message would take to go from a source to destination. What I mean by that is, as part of the mesh network itself, when you configure the network, there are these periodic heartbeat messages that are sent among all the nodes that help to get a sense for how far the nodes are. And where that matters is, this is where there is a TTL field, the time to live field that is encapsulated in each packet comes into play. What this field tells us, every time the message is retransmitted by a relay node, the TTL field is decremented by 1. Once TTL goes to 0, the message is not transmitted anymore. Obviously, you need to make sure that your TTL field is set to an optimal value so that any two nodes can communicate with each other within a given mesh network. So practical limitations, practically I've seen deployments where TTL doesn't typically exceed more than 4 or 5. Effectively, it means that you have taken 4 or 5 hops to reach any 2 points within the network. So that kind of roughly gives you the worst case latency in a mesh network for a message to go from a source to destination. And the rest of it is, I mean, it's the whole BLE mesh is running on a sort of a BLE physical layer. Typically, it runs at 1 Mbps. And with 4 to 5 retransmissions, you could calculate, like, what's the worst case latency. There's one additional thing that is built into the mesh protocol itself, where you can use a status message or an acknowledged message to get a confirmation that whatever message you have sent has been received. Hopefully that answers the question.
Yeah, and another question, possibly related to that: how does the network cope with lost messages?
Oh, yeah, it kind of dovetails into what the last statement I made there. Most messages within a mesh network are sent without the need for an acknowledgement. So the message is lost, it's lost, it's lost. And if a message is critical, that's when you would send an acknowledged message. Basically, whatever, just telling the destination once you receive the message and you take the relevant action, send me an acknowledgement message. Obviously, messages which are get messages, essentially get me the temperature. There's an inbuilt mechanism where, okay, fine, I sent a read temperature message and I haven't received in a certain amount of time, I retransmit it. So there is an inbuilt acknowledgement baked into those. But I mean, if you really want to make sure that your message, even a set message where you're saying, okay, set the thermostat to this level is received back, you would use what's called as an acknowledged message. And if a packet is, I mean, typically the data itself, the message itself is sent on 3 separate channels, 37, 38, 39. And whoever is listening on those channels. And those channels are also picked position-wise. If you look at the spectrum itself and where they fall, they try to avoid interference with other networks. Other Wi-Fi is another network that is quite predominant in the 2.4 gigahertz spectrum. So by utilizing these 3 channels, which are spaced apart and spaced in the gaps within the Wi-Fi channels, the reliability is fairly high for the messages to go through. But if you want to ensure that the message is absolutely received, you would use what's called an acknowledged message.
And another question that just came in: do messages get split into multiple packets?
There is a provision for that. In fact, if you look at the Bluetooth mesh stack, Within that stack, there is something called the lower transport layer. Let me just see if I can. Okay, right here. So segmentation and reassembly is allowed within the protocol itself. So if the message is too long to fit within one PDU protocol unit, there is a provision where it can be segmented and sent as multiple packets. So there is provision within the protocol to allow that. I haven't actually seen a real-life implementation which used this sort of segmentation of large packet sizes, but it's built into the protocol. So if a use case demands it, it's available.
And what is a packet size?
I don't know the exact number, but it is, since it runs on the Bluetooth low energy advertising payload, ultimately the payload that goes out on the channel is an advertising payload. I'll be guessing at this. I mean, it's somewhere in the 30 to 40 bytes is the payload size. Of course, you got to think about all the other stuff, all the headers that you need to add for the mesh message itself. So the actual application payload is fairly small.
And just one last question here to finish us off here at the end of the hour is where are you seeing BLE mesh being used most yourself?
As I mentioned earlier, a lot of lighting customers, a lot of lighting related applications. Also, this sort of systems, wireless networks, wireless sensor network systems within industrial settings as well as buildings, multiple sensor nodes talking to the lighting platform, lighting fixtures. So I would say lighting is the biggest application where we see. The other interesting thing that's happening within the lighting space itself is that lighting is becoming a fundamental, foundational platform. So you do see incorporation of a lot of additional sensors within the lighting fixtures. So the majority of activity as far as BLE mesh is concerned, and where we see the majority of the activity is within the lighting space. And with lighting becoming foundational for buildings and industrial settings, it's definitely an interesting development.
All right, well, folks, it looks like we are all out of time. I want to thank everyone here for attending, and a special thank you to our presenter. A few people had also asked if we would have these slides available in a PDF form on demand at the end of the webinar, and that will be available for attendees and can be found on All About Circuits. There will be a follow-up email that will provide you those slides as well as this presentation once again. So thank you, Pavan, for your time, and thanks everyone for attending.
Thank you.